Hello everyone, this is Dr. Debajyoti there. Today we will be talking on photoelectric effect, and this photoelectric effect in the form of PPT presentation. I will try to first state the objective of the course, objective of this particular class. Then I will go towards the detail of the invention and the applications of photoelectric effect, and towards one open-ended discussion regarding the further aspects and applications and development after the invention of photoelectric effect. Before knowing the photoelectric effect, we will start from the very beginning, that is interaction of photon with matter. This is very important aspect of physics, which opened the door of the question that the light, what it is a particle or one wave. Actually, light is having dual identity. Sometimes light behaves as wave, sometimes it behaves as particle. For example, in case of photoelectric effect, Compton effect, light behaves as particle, and for the reflection, refraction, this kind of physical phenomena, light behaves as wave. The objective of the class is to understand first the different types of interaction of photons with matter. If the photons are interacting with the matter, what will happen then? Then understand the particle nature of radiation, then wave particle duality, that what I was talking about, that is the light is having dual characteristics. Sometimes it is behaving like wave, sometimes it is behaving like particles. Then the photoelectric emission, the photons are interacting with matter, then the electrons are emitting, is called photoelectric emission. The relation with frequency and intensity, what is work function, then we will understand what is stopping potential, and few applications of the photoelectric effect such as night vision camera, smoke alarm, solar cell, etc. In this picture you can see one plane that is operated by solar power, and that was landed at Ahmedabad in 2020, and it was in a mission to roam the world without fuel, using solar light as fuel. Only by applying the solar cell and the activity of photoelectric effect, the plane was designed. And this man is the creator behind this invention, Sir Albert Einstein. Let's now see different types of interaction with photon. The interaction of photon with matter is so important aspect in physics that the first, it can create coherent scattering. Second one, it can create Compton effect. Third one, it can create photoelectric effect, that phase we will discuss today, and pair production, and fifth one is photo disintegration. These 5 phenomena are so important in physics that for each discovery, scientists got Nobel Prize. Rayleigh and Thomson for discovering the coherent scattering, then Arthur Holly Compton for the discovery of Compton effect, Einstein for the discovery of photoelectric effect, Anderson and Dirac for the invention of pair production, and Chadwick and Goldhaber for the invention of photo disintegration. And there are some classifications of energy level of the interacting photon, depending upon which the phenomena can vary. What these are? First one, when the energy of the interacting photon is very less, it is less than 10 kiloelectron volt, and it is coming towards the matter, and it is interacting with the outer shell electrons. It is not actually interacting, it is being deviated by, then it is creating coherent scattering. When the energy is moderately high, of the level of 10 to the power 4 to 10 to the power 5.5 kiloelectron volt, it can show two types of phenomenon. First one is Compton effect, second one is photoelectric effect. When the photon is interacting with outer shell electron, then it can create Compton effect. When it is interacting with inner shell electron, it can create photoelectric effect. Now the energy is moderately very high, it is above 10 mega electron volt. It can directly collide with the nucleus of any matter and creating one electron hole pair. That is called the pair production. And finally, when the energy is too much high, of the level of 1.02 mega electron volt, it can create photo disintegration. That is, it can completely annihilate. It can completely annihilate the matter, and electron, proton, neutron all will be separated out. In the graphical form, now I will show you. Suppose this is the photon. The photon is coming towards the outer shell electron, and energy is moderately low. So photon is being deviated, and it is called coherent scattering. Now the second one, the photon is having much more energy. It is colliding with outer shell electron. Then it can create Compton effect. Now if the energy is more higher and it is colliding with inner shell electron, it can create photoelectric effect. That it is supplying energy, sufficient energy to the inner shell electron to be liberated from the electronic shell, overcoming the its threshold energy or work function of the material. It is called photoelectric effect. Finally, when it is colliding with the nucleus, one electron hole pair is being created. It is called pair production. And with sufficient amount of energy, it is colliding with the nucleus, and it is the electron, proton, neutron order being fragmented. It is called then photo disintegration. If we consider the background of the invention, in 1900, during the 1886 to 1902, Wilhelm and Philip, they first guessed about the phenomena of photoelectric effect. That is, yes, there is a probability that with sufficient energy, photons are colliding with the metal surface, and it is supplying sufficient amount of energy to the electrons. The electrons can overcome the surface energy potential barrier and can be liberated from the metal surface. In 1900, Max Planck first gave the famous Planck hypothesis about the quantization of energy. That is, energy comes in the form of packet or quanta, and this quanta can collide with the electron. After that, in the year 1905, Sir Albert Einstein, he published a famous paper which is known as photoelectric effect, and for that he got Nobel Prize. Not only that, in 1905 he also published two more famous articles. One is about general theory of relativity, and another one was about Brownian motion. But he was given the Nobel Prize for this invention because it changed the livelihood of the upcoming generation. Suppose from the X-ray machine, if you are creating some photons, then the photons can collide with the electron. Unlike the electron tube, in electron tube what happens? Some high energy electrons collide with the metal and X-ray is being liberated. It is the process reverse to that. The photoelectric effect, only the photons will hit the target and electrons will fly out. If you consider this tube, suppose this is the light, it is coming from this direction and it is colliding with the metal surface, and electrons are being liberated, and if the electrons are flowing in a particular direction, it can give rise to some current, and the flow of current in this particular circuit can change, and you can identify the existence of photoelectric effect. With graphical picture, I am showing you some more detail about that. Suppose this is the photons of blue light. These are colliding with the metal surface, and I am getting some electrons are being liberated, getting sufficient energy from the photon. If I repeat this phenomena for red light, probably I will not get photon. But if I increase the intensity also of the red light, then also it is not possible to get photon for the particular light. So what I get, the emission of photon, emission of electron or energy of the photon doesn't depend upon the intensity or brightness. It actually depends upon the color. That means the frequency or wavelength of the light. Here comes the Planck hypothesis, where he told the energy is quantized and energy E is equals to h times, that is Planck's constant, times nu, the frequency of the light coming, or you can write it hc by lambda in this form. So energy only depends upon the frequency of the light, not the brightness. So for the blue light, if I get sufficient energy, it is not mandatory that for high intensity red light I will get it. If I calculate for visible light, if the wavelength I consider from 400 to 782 nanometer, the energy generated is in between 3.1 to 1.6 electron volt. This is the light spectrum. For that I am getting this amount of energy. Now I am coming to the phenomena of photoelectric effect. In photoelectric effect, there is another function which is called the work function of the material. The electrons are bound to the surface of the material with some force. That is called the work function of the material. The work function is a solo characteristics property of a particular material. It depends upon material to material. It may vary for different materials. If light is coming in this direction, it is colliding with the outer shell electron, and electrons are absorbing sufficient amount of energy from the light coming, then it is being liberated. So of course it has supplied sufficient amount of energy to overcome the surface energy potential barrier, which is called the work function of the material. The minimum amount of energy which is required to liberate a photon from the metal surface with zero kinetic energy is called the threshold energy of that particular electron. So now I am moving towards the equation of photoelectric effect. Here comes the equation of photoelectric effect, that is E equals to half mv square, that is kinetic energy of the electron, is equals to ev, that I know. In case of Cooley's tube we have understood this equation, is equals to h nu. H nu is the energy of the light incoming minus w, that is the work function. So h nu minus w means h nu amount of energy is supplied minus the work function. The remaining amount of energy will be acquired by the liberated electron in form of ev, or if you call the kinetic energy, in form of half mv square. This is in terms of frequency. You can write it in terms of wavelength also. For different metals, the work function and is given here in the form of chart. So you can easily calculate that which amount of energy is to be supplied in order to generate the free electron with the help of photoelectric effect from this kind of metal surfaces. Now I am talking about one application of this photoelectric effect. This night vision camera. We are all aware about the night vision camera and its applications. In very less amount of light, where lux is very low, lumens is also very low, you can generate the image in the night time also. Suppose this is the camera and this is the optical lens. In this optical lens there is some photophosphorescent material. The small amount of light is coming and it can create photoelectric effect. And for photoelectric effect, huge amount of electrons will be generated. Then there will be photomultiplier which can multiply the amount of electrons generated, and it can create the image for that. So first, from the source, the light coming towards the camera is very less, but it is creating huge number of electrons which is carrying the information about the image, and from that we can construct the image of the particular object in night time also with very less amount of light present. Another important application is smoke detector. This is the construction of smoke detector. From this particular direction, light is being emitted and light is passing in straight line towards this direction. Now there is one opening in the smoke alarm. In this circular aperture there is some opening. In this through this opening, suppose there is a fire and some smoke is coming towards the chamber, and the smoke particles will interact with the light coming through, and it will be diffracted in all possible directions. Suppose after interacting with the smoke, the light is diffracted towards this direction of the lens. In this particular direction lens, there is a photophosphorescent material which is called photocell, and photon falling on the photocell will create electrons. The electrons flowing in a particular direction will create current, and flow of current will switch on the alarm, and thus the smoke detector works. The last one is the application of the solar cell, and this invention changed our mankind of upcoming generation, because we have already exhausted all kind of fossil fuel, and just amount of fossil fuel remaining with us will be exhausted in few decades. This is the alternate source of energy where no turbine is required, no rotation of motor turbine is required. Only sunlight is required, sufficient amount of sunlight falling on the solar cell will create current, and through that current you can charge a battery and you can use as per your need. And because of this groundbreaking invention, Einstein was given the Nobel Prize. So I hope we got some initial idea about the photoelectric effect and interaction of photon with matter. So the question is now, light is a particle or a wave? The answer is both. Thank you for listening, and we are taking home this information. The interaction of photon with matter can be classified into 5 different groups. There is coherent scattering, Compton effect, photoelectric effect, and then pair production and photo disintegration. We learned about wave particle duality, we learned about photoelectric effect, work function, threshold energy, etc. Also, we have learned some application in mankind. So if you scan this image, you will be able to play some quiz. Let's try. If you understood this video, you will be able to answer the quiz, and also from this link you can give me feedback about this lecture. Thank you.